Carpe diem, I am Zach, presenting statistics on the average daily phone usage of Singaporeans. The claim is that Singaporeans average 4.51 hours daily on their phones, made by Statistica and Singapore Business Review. Therefore, my null hypothesis, H0, is that Singaporeans spend 4.51 hours daily on their phones. On the other hand, my alternative hypothesis, H1, is that Singaporeans spend more than 4.51 hours using their phones daily. I chose the alternative hypothesis as I believe that the people are more technologically savvy and dependent on the handheld devices nowadays. To test my hypotheses, I gathered data from 30 Singaporeans and organized it in Excel to facilitate further calculations. This shall serve as our sample data. There are 30 rows of hours that different Singaporeans spend on their phones daily, meaning that the size of my sample n is 30. To find sample mean x bar, I used the average Excel function. To calculate the mean of the sample x bar, I added all the hours that each individual spends on their phones daily and then divided by the size of the sample n. To find my sample standard deviation s, I used the standard deviation Excel function. Standard deviation is the measurement of how spread out data is in relation to the mean. To calculate sample standard deviation s, the formula is to square root the open bracket sum of each value from the sample subtracted by the sample mean x bar closing bracket squared divided by the sample size subtracted by 1. In conclusion, my sample mean is 5.53 hours and the sample standard deviation s is 1.96 hours. Now we can discover the test statistic T0 using T0 equals to the sample mean x bar subtracted by the population mean mu divided by the sample standard deviation s divided by the square root of the sample size n. This process is called the t-test, which I am using as the population standard deviation sigma is unknown. So using the formula, my test statistic is 2.845 assuming population mean mu is 4.1. Afterwards, we can calculate the possibility value, p-value of the test statistic, which represents the probability of obtaining the observed result, assuming the null hypothesis H0 is true. To calculate the p-value of my sample, I use the right-tail distribution function in Excel, p-value equals to the function shown, where x is the value of the t-test T0 and the degree of freedom is the sample size n minus 1. My sample p-value is 0.004. And since the significance level A, which is the measure of strength of the evidence, is 0.05, my sample p-value is less than the significance level. This means that there is sufficient evidence to reject the null hypothesis. This is because it is highly improbable that 4.51 hours is the real average. Last but not least, when significance level A is 0.05, there is a margin of error which one must find for the confidence interval. The margin of error can be found using the shown formula, where TA divided by 2 is the critical t-value for the given significance level, S is the sample standard deviation, and N is the sample size. To get the critical t-value, find the degrees of freedom, which is the sample size n minus 1. Use the t-table to find the row corresponding to the degrees of freedom and the column for a divided by 2 in order to find the critical t-value. Alternatively, I use the Excel function which will output the margin of error. My sample's margin of error is 0.732, allowing me to find the lower and upper limit of the confidence interval. The lower limit of the confidence interval is the sample mean subtracted by the margin of error, and the upper limit is the same but addition instead of subtraction. Thus, my 95% confidence interval is as shown here. I believe there is more than sufficient evidence at 5% significance level that the population mean mu is more than the supposed 4.51 hours. Therefore, I am 95% confident that the true population mean mu falls between this range. It is likely that the daily average phone usage of Singaporeans is more than 4.51 hours, supporting my alternative hypothesis H1. To summarize, since the p-value is less than the significance level, the null hypothesis is rejected. However, the 95% confidence interval supports the alternative hypothesis. Thanks for listening.